南的一家是吧，给人这样做，那至少我们还能省一成的运费。手上组一罐，就相当于说材料，那它会就是这个事儿，那个张经理，对，核实一下那个他那个邢台咱肯定是搁不了，就邢台和板材都得带协哈，跟国宾再合一合。
Hello everyone, welcome to our live stream. I'm Alan. Today we are going to talk about a bridge type that is highly competitive for long-span projects in mountainous areas, the open wide continuous rigid frame bridge. Let's start with the basics. The open wide continuous rigid frame bridge, also known as the arc girder composite continuous rigid frame bridge, is developed by hollowing out the web of the box girder at the root section of a conventional continuous rigid frame bridge. By determining reasonable root depths, open web segment length and depth of the upper and lower chord segments, and an open web section is formed where the lower edge of the lower chord and the lower edge of the solid web segment are continuous and transition smoothly. In this hollowed out area, the lower chord, upper chord, and the main pair are connected to form a triangular zone. The lower chord preliminary functions under compression, fully leveraging the high compressive strength of concrete. At the same time, this design reduces the structural length of the solid web segment, optimize structural stress, and thus enhance the spanning capacity. According to research, the economical applicable span range for this bridge type is 200 to 400 meters. Structurally, it mainly consists of the pier, the lower and upper chords in the root hollowed out region, the conventional solid web segments, and the closure segments. Now, what makes this bridge type structurally unique? Overall, the open web continuous rigid frame bridge remains a pre-stressed concrete girder bridge in terms of structural behavior. That means it retains all the well-known advantages of conventional pre-stressed concrete continuous girder bridges: convenient cantilever construction, smooth rigging comfort, strong adaptability to root alignment changes, and mature construction and maintenance technologies. But on top of that, it significantly improved the spanning capacity of concrete girder bridges. Compared with traditional continuous rigid frame bridges, the structural system of the open web bridge has several distinctive characteristics. First, in the hollowed out triangular zone, the lower chord is preliminary under compression, exhibiting arc-type stress characteristics, while the upper chord is primarily under tension, which can balance the compression force in the lower chord. Moreover, the hollowed out triangular zones on both sides of the main pier are symmetrical, so the compression forces in the lower chords and the tension forces in the upper chords on both sides essentially cancel each other out, forming a stress system. Second, the pier root section, which bears significant negative bending moment, transforms from a beam-type sectional stress pattern to an open wide triangular zone frame stress pattern. This significantly improved the structural load-bearing efficiency of the pier root section. Third, hollowing out the triangular zone reduces the length of the mid-span solid web segment, thereby decreasing both the stress and deflection of the mid-span portion. Fourth, the presence of the lower chord effectively reduced the pier height and improved the stability and the stride performance of tall piers. Fifth, hollowing out the root region reduces uh, Fourth, the presence of the lower chord effectively reduces the pier height and improves the stability and stride performance of tall piers. Fifth, hollowing out the root region reduces the structural dead weight, lowers the scales of substructures and foundations, and improves the structure's seismic capacity. Now, let's move on to the general layout. Open wide continuous rated frame bridges can be arranged as simple as single main span, multiple main spans, or single T configurations. The piers can be designed as double-like thin-walled piers or box-shaped column piers. In addition, this bridge type can be combined with conventional continuous rigid frame bridges to form arrangements with large and small spans, which enhance adaptability to varying terrain conditions. Similar to conventional continuous rigid frame bridges, the piers of an open wide bridge are rigidly connected to the substructure, eliminating the need for large bearings. The piers bear the actual forces, bending moments, and longitudinal displacements of the girder caused by pre-stressing, concrete shrinkage and creep, and temperature changes, all transmitted from the superstructure. The shear force at the pier base, induced by longitudinal displacement of the superstructure girder, decreases with increasing pier height and decreasing pier stiffness. Therefore, when arranging spans, it's important to select appropriate pier heights and cross-sectional dimensions based on engineering experience. For double limed thin wall piers, the pier height should generally not be less than uh, 1 of 5 to 1 of 4 of the distance between the pier and the 0 point of longitudinal displacement caused by uniform overall temperature changes. Next, let's talk about the general construction method. The construction of the superstructure typically begins with the open wide segment. After the upper and lower chords converge, the construction method transitions to the balanced cantilever casting of the conventional solid web segments using foam travelers until closure is achieved. Overall, the construction method is quite similar to that of a conventional continuous rigid frame bridge, and the main distance line lies in how the the open wide segment is executed. Since this open wide structure is usually located atop tall piers, formwork construction is difficult. This brings certain particularities, imposes high demands on construction equipment, and requires close attention to stress and deformation control throughout the construction process. It's also worth noting that during the completed bridge and subsequent operation phases, the lower chord segments in the open wide region preliminary function as compression and shear resisting members and are typically provided with fewer longitudinal pre-stressing tendons. Although the upper chord segments are pre-stressed members, their cross-sectional dimensions and flexural stiffness are smaller than those of the lower chord. During construction, neither the upper nor lower chord structure can independently withstand the construction loads of long cantilever foam traveler. Uh, Measures such as temporary supports or stay cables are required to accomplish the cast-in-place cantilever construction using foam travelers. The open-wide continuous rigid frame bridge is particularly suitable for long-span bridges on tall piers in mountainous areas. Preliminary research indicates that its economic applicable span range is 200 to 400 meters. This bridge type is constructed using the balanced cantilever form method, and its engineering cost in these, as well as operational maintenance technical requirements and costs, the comparable to those of conventional continuous rigid frame bridges. Admittedly, this bridge type is more complex in terms of detailed design, pre-stressing layout, and construction of the open wide segment compared to traditional rigid frame bridges, which imposes higher demands on construction equipment and process control. However, its outstanding spanning capacity and structural performance in complex environments such as deep mountainous valleys make it a highly competitive option for long-span bridge schemes. As design theories and construction technologies continue to mature, the open-wide continuous rigid frame bridge is destined to play an even more important role in future transportation infrastructure construction. If you are currently involved in or planning a long-span bridge project, especially in challenging mountainous terrain, and you are looking for reliable, professional formwork solutions, we love to hear from you. Reach out to us for a consultation, technical discussion, or just to learn more about how we can help you to make your project a success. Thank you for watching, and we look forward to connecting with you.